continue for this presentation. Now we will be looking into friction and numerical problems on motion of a single body in a plane. And the last class we have discussed what is friction, what are the types of friction, and what is friction coefficient, limiting friction, etc. So let us apply here and find what is the coefficient of friction. We have studied the concept of limiting value, how much the force is required in order to move an object and how much a force is required for an object in order to keep them in a state of rest. Yes, here the term force is everything. So with a force you can make an object to move, or you can stop an object, or you can reverse an object into the opposite direction of its movement. So force is everything here. This is what which is highlighted and rightly said by Sir Newton, and we will be using for module 1 and for module 2 also the concept of force, the law 1, 2 and 3, which we can apply here in this whole engineering mechanics. And right now we will be looking into the concept of friction. How much is the impact of friction in an object, in a mechanism? So let us see that and let us quantify by using some problem. So let us solve some problem and understand the concept. Yes, these are the points to be noted while you are solving the friction oriented problem. If any condition is given, if any case is given, what you have to do is first draw the free body diagram, and you have to remove the object which is given and where the object is supported or it is hung. So you have to remove everything and only you have to mention the force in a single point. So at a point, how many number of forces are acting, and this is known as the free body diagram, and you have to draw that, and after that you have to take a reference axis. Either your object can be in a horizontal plane or it might be in an inclined plane, so you have to make a reference axis. So we have to choose the reference axis in such a way that one axis must be along the direction of motion, so where the object is intended to move, and that line could be taken as the x-axis or the movement of the axis as reference axis, and perpendicular to the movement you can take it as y-axis. In drawing the free body diagram, we should always remember that the self weight of an object. So if you have any object, it will definitely have its mass, and you have to consider that. What are the other external forces which are acting has to be considered while drawing the free body diagram. When we are speaking into friction force, we speak about some roughness is there. So what is the roughness here? And we will be quantifying the amount of roughness from 0 to 1. This we will be quantifying by using two parameters, that is frictional force and normal reaction. If a surface is rough, you have two parameters, that is a frictional force and a normal force, that is F by N. And you can use the following equation, that is summation of F of x equal to 0 and summation of F of y equal to 0. After drawing the free body diagram, you can find the friction coefficient by using F by N ratio. Let us take a problem, and here a block is shown in figure is just moved by a force 200 Newton. So this is a block which is being placed in a floor, and the force which is acting in the block is 200 Newton, which is an angle of 20 degree. So what we have to do is the weight of the block is 600 Newton and determine the coefficient of static friction between the block and the floor. So if the object is dragged, there will be friction between the two objects. So this is called a dry friction. And if the object is moving in one direction, you will be having friction at the opposite direction. Since the force is acting at right hand side, you will be having friction in left hand side direction. So this is the free body diagram. And rightly we mentioned earlier, if an object is there, you have to mention the self weight. So the self weight is given here as 600 Newton, and if any force is acting downward, you will be having a reaction, that is upward, which in friction, which is known as normal thrust, which will be acting at upward. So this is the free body diagram. So now we can resolve this into horizontal and vertical axis. So what we need here is friction coefficient. So what do you mean by friction coefficient is F by N. So F is mu in terms of N. So if you find N, you can find the frictional coefficient. So you know the force here. They have already given the force and you have to find the N value. If you find that, you can find the frictional coefficient. Yes, let us resolve all the forces into horizontal direction. So you have 200 Newton. If you resolve that, 200 cos 20, which will be acting right hand side. So plus 200 cos 20, and the frictional force will be acting at negative direction, that is minus mu n. So minus mu into n. So the constant is mu n here, and this is the unknown. So you can take this outside, and mu n will be 200 cos 20, that is 187.938. So this will be your mu n. Let us keep this, and we will be resolving it vertically. So if you resolve vertically, n is plus. So n is acting upward, that is plus n, and 600 is acting downward, that is minus 600, and 200 can be resolved vertically, and 200 sine 20, which is plus. So if you resolve this, you will be getting n, and the only one unknown is n here. So n we have found out as 531.59. So if you substitute in this equation, you will be getting mu here. So the coefficient of friction here is 0.35. The coefficient of friction, which will be 0 to 1. So this is the value. So whenever you are getting the coefficient of friction, make sure that you are getting from 0 to 1. Yes, let us take the next example. A block of mass 20 kg is placed in an inclined plane as shown in the figure. So this is the figure is given in the problem, and this is a block at an angle of 30 degree. The block has a self weight of 20 kg as shown in the figure, which is subject to a force P. So this force along with the inclined plane. So this is parallel to the inclined plane, taking the inclination of the plane with respect to horizontal as 30 degree. So this angle is mentioned as 30 degree. The coefficient of friction as 0.24. So mu is given here. Determine the value of P for impending the motion of block. That is, first case is the value of P for impending the motion down the plane. What are the question which is asked here is, first thing, if any block is placed in an inclined plane, you don't apply a force, this will dragged into downward according to the coefficient of friction. So let us check that if the coefficient of friction which is enough to handle the object in a static plane, or will the object drags down. So let us find these two cases. If a force is applied to the upward direction, is the force is enough? So what is the minimum number of force which is required to pull the object up, and what is the force if you give which is not enough, the object will go downward. So this is the two cases. So this is a practical case. You can imagine this as a car, and if you don't give any force, what will happen? It will drag downward. So this will be according to the inclination and the amount of coefficient of friction. Okay, let us identify that. So first one, let us assume that the object is moving downward and the force is pulling the object downward, and let us take the P at left hand side direction. Okay, let us draw the free body diagram by using the given data. So you will be having a self weight which will be always acting in a downward direction, which is purely 90 degree. You can see that self weight which is acting 20. So it is given in terms of kg. We will be finding in terms of force. So if you want to find in terms of force, W into G. So W here is 20 is given, and you have to multiply into 9.81. So you will be getting the self weight, and if there is an object, you will be having a support. So the support will be always perpendicular to the object. So this is N, and if the object is going downward and it is pulled downward, the friction will be acting opposite to that, that is upward, F equal to mu into N. So this is the free body diagram. Okay, now let us find the force. What is the requirement here is, what is the force which is required in order to drag the object. So if the amount of friction is sufficient to hold this object, what will happen? This will not drag downward. So let us check that if the friction is enough or you need some force to drag backward. So if you need to drag the object down, so what you can do is you can direct the load, which is P, this is unknown P. So let us resolve this vertically and horizontally and find the unknown force. If you resolve vertically, the movement of the motion, which you can take as x-axis, and perpendicular to that is y-axis. This object moves parallel to the plane. So we can take this as the x-axis, and this, since this is the plane, and the perpendicular to this is y-axis. So if you resolve it vertically, and you have a 20 into 9.81 force, and if you resolve this from the vertical, you have 30 degree. So if this is the plane, this is 30 degree, and if you drop a horizontal line here, you will be getting 30 degree angle. So the rest of the angle will be 60 degree. So that is what it is written here, and you have a 60 degree angle with respect to the axis. So if you resolve it vertically, you will be having minus 20 into 9.81. Its angle will be with respect to horizontal is 60 degree, and it will be sine 60, which will be negative, and minus 20 into 9.81 sine 60 degree, and you are having an upward force which is N, this is plus N. So if you take this outside and you can find the N value. So if you resolve it horizontally, you are having a force P which is acting left hand side, which is minus P, and a right hand side you are having F, that is mu N, that is plus mu here is 0.24, and N we have already found out, so plus mu into N. And another force, if you resolve this horizontally, you will be getting in terms of negative direction, so minus 20 into 9.81 into cos 60 degree. So if you resolve this, you will be getting 57.320 Newton. So now from this figure, if you pull with a force of 57.32 Newton, then this object will drag to the downward direction. Unless or otherwise, if you are having friction between these two surfaces, so this object will stick on to this place, so due to this friction. So if you pull this object with a force of 57.32 Newton, then the object moves in a downward direction. Okay, if you want to move this object in a upward direction, so the value of P of impending motion up the plane. So what is the force which is required to move this object in upward direction? So the same thing we have to apply here, and this is our free body diagram. Only thing is everything will be same, and instead of downward direction of P, you have to consider upward direction of P. So let us resolve vertically and horizontally. So when you resolve vertically, 200 into 9.81 sine 60 degree, so which will be acting downward, and N will be acting upward. So we have 20 into 9.81 into sine 60. So if you multiply, you will be getting the same value as the reaction, that is normal. And if you resolve it horizontally, you will be getting plus P, and you have plus P here, and minus mu into N, that is friction. Minus mu into N is here, so mu is 0.24, and N we got is 169.914, and the other force is acting downward. So if you resolve this horizontally, you will be getting 20 into 9.81 into cos 60, which will be minus. So the only one unknown is P here. So you can take remaining thing outside, and you know that the final solution is 138.879 Newton. So if you apply a force of 138 Newton, you can drag the object upward. So right now we have found out for this object. So this object is having nearly 200 Newton of force. So if a 200 Newton of force object is here, which is in a sloped plane, so you just now arrived the force which is required to drag downward and the force which is required to drag upward. So if you are not providing any force, what happens? Due to the friction, the object does not move upward or downward. It will be in a state of rest. Yes, let us take the next problem, and a small block of weight as shown in the figure, which is placed on a 30-degree inclined plane with a coefficient of friction of 0.25. Determine the horizontal force to be applied for first one impending the motion down the plane and impending the motion up the plane. So what is the difference between the last problem and this problem is you have to find the horizontal force required. So there the force was indicated along the direction of x-axis, and here they have given a condition that the force has to be applied horizontally. So the object is at an inclined plane, you have to apply a horizontal force. Note that you will be having an angle. So this angle will be the same angle as the slope. These two are parallel lines which are horizontal lines. So the opposite angle will be equal. So hence we have written it as 30 degree. So you have to apply certain force in order to drag this object downward or to pull this object upward. So that force is taken as P, and the angle is 30 we have found out. And if you have a 30-degree angle, if you draw a horizontal line here, the angle will be 30 degree. So the rest of the angle will be 60 degree in order to get a right angle triangle. So this angle we have found out as 60, and let us start resolving. So this is the free body diagram. If you resolve vertically, you are having a downward force of 1000 Newton, and the angle here is 60 degree. So 1000 sine 60 degree, which is minus 1000 sine 60 degree. So n is acting upward, so you have plus n here, and if you resolve this p, it will be acting upward direction. So p sine 30, so plus p sine 30 equal to 0. Okay, if you need n, you can take this outside. Now let us resolve horizontally. First thing you have minus p cos 30 degree. So this is left hand side, which will be minus, and minus p cos 30 degree, and at right hand side you have f equal to mu into n. So mu we already know, which is 0.25, is given here, and n we have found out as 866.025 minus 0.5 p. So this we have applied. So this component is plus, and another component is 1000 into cos 60, which will be acting left hand side, minus 1000 into cos 60. So if you multiply it inside, you will be getting this term, and you can simplify, you will be getting 286.068 Newton. So if you apply horizontal force of 286 Newton, you can drag the object in downward motion. What is the force required to impend the object up the plane? And if you want to move it upward, you have to mark it as in right hand side. So you have to push into the upward direction. So the force should be horizontal, and it will be 30-degree angle, and the rest of the angle here will be 60 degree with the plane. Let us resolve it horizontally and vertically. if you resolve vertically, you will be having 1000 sine 60 degree, which will be downward, so minus 1000 sine 60 degree, and upward force will be N, which is plus N, and you are having an inclined force here, which is P into sine 30 degree, which will be acting downward, so minus P sine 30 degree. If you can take rest of the things outside, you can find N as P sine 30 degree plus, if you simplify this, you will be getting 866.025, and you can resolve it horizontally now. 1000 into cos 60, which will be left hand side, and it will be minus, so 1000 cos 60 degree, and the same left hand side will be the force. So here friction will be opposite direction, since it is moving at upward plane, so the friction will be at negative direction. So note here that the friction is along with the direction of motion. So the motion will be along this plane, opposite to the direction will be downward. So this will be along the parallel direction with respect to the plane, and mu into n is given here. So you know, since it is acting left hand side, which is minus, mu is given as 0.25, and n we have already found as the value here, it is written, and the force P is acting at an angle of 30 degree, P into cos 30, so P cos 30, which will be right hand side. So if you simplify this, the only one unknown constant is P here, so you can multiply this value inside, and you will be getting P as 966.944 Newton. You need a horizontal force of 966.9 Newton in order to move this object in upward direction. Yes, let us take the next problem. A crate is shown in figure, and which has a mass of 580 kg. So this is the object, and which is having a self weight of 580 kg, which will be acting vertically downward, and if P equal to 6000 Newton, so there is a force which is acting, which is P acting at horizontal direction. This force is 6000 Newton. Find the magnitude of frictional force which acts on a crate. What is the frictional force? You have to find, that is F. You have to find the frictional force F. We know frictional force F is mu into N. And next thing, what value of P will cause the crate to have impending motion up the plane? Find the minimum value of P which is required to keep the crate from sliding downward the plane. You have to give a minimum number of force in order to stop the object or to make this object rest, and for what range of P will the crate remain in equilibrium position as shown in figure. This is the third case. What is the force which is required to move this object upward, and force required to move this object downward, and force required to keep the object in equilibrium? So these are the three cases. So let us find one by one here. So a force P is given, and you have to draw the angle. So if you draw a horizontal line along this plane, from the horizontal line, this crate is at an angle of 35 degree. So you will be having, so if I am drawing a parallel line towards the slope, so I will be getting the horizontal angle as 35. So this is the horizontal angle with respect to the force. We have found out this, and if you want to find out the rest of the angle, so you can draw a horizontal line here, and if you draw a horizontal line, if this is 35 degree angle, so with respect to horizontal, this angle will be 35. So the rest of the angle will be 55 degree. If you subtract 90 minus 35, you will get 55. So now we got the angle here. And what are the forces which are acting here? One thing is a self weight, which is given as 580 kg of mass. So you have to convert in terms of force here. So 580 into 9.81, which will be acting downward, and so your axis will be where you have the movement of this object. So this object is going to move in the sloped manner. So this will be x-axis and perpendicular to this will be y-axis. And next thing is you have a normal force, which is the support reaction, which is acting along the y direction. Yes, these are the components of free body diagram. So now the free body diagram is ready and you can resolve it. So if you want to move this object upward, so you have to direct this force in left hand side. So in order to move upward, so if we have directed here, you have to resolve it vertically. If I am resolving, there is a downward force which is minus 580 into 9.81 into sine 55 degree. This will be negative 580 into 9.81 into sine 55, and you are having a force. If you resolve this, you will be getting a negative value, which is P into sine 35 degree. So after taking this outside, so N, which is acting upward direction, which will be plus here. So after taking this outside the equation, so both the negative value vanishes and N equal to this value you will be getting. And let us keep this value, and what you can do is you can resolve horizontally. If you resolve 580 into 9.81 cos 55 degree, so this will be acting at right hand side, and plus 580 into 9.81 into cos 55 degree. So all the values are here. The only one unknown is P here. So rest of the things are known. So you can simplify, you will be getting P equal to 6550 Newton. So if you apply this 6550 force, you can move this object upward. So you can move this crate to the upward direction. And the magnitude of frictional force. So let us go to the next thing. If P equal to 6000 Newton, find the magnitude of the frictional force which acts on the crate. Let us find the frictional force. So if the force which is acting, resolve it vertically in order to find the frictional force. So you can find this F. We already have resolved it vertically. 580 into 9.81 into sine 55, which will be acting downward, and this is here, and the N will be acting upward. Note that here instead of P you have to substitute 6000. So 6000 into sine 35 degree. So minus 6000 into sine 35 degree. Only one unknown is N here, and you can take it outside and find the N, which we got it as 8102.26 Newton. For the force of 6000 Newton, normal force, which is N, we got it as 8102. So if you got the normal force, you can find the frictional force. So mu into N, we have taken mu as 0.25, and if you multiply 0.25 into this value, you will be getting 2025.567 Newton as the frictional force. Okay, next let us find the value of P for impending motion down the plane. So you have 580 into 9.81, and if you resolve this vertically, you have 55 degree angle, so sine 55. So this will be acting at downward direction, and you have upward force, which is N, so this is plus N, and this will be minus. Next you are having a force P. If you resolve this vertically, so P into sine 35 degree is plus, so plus P into sine 35 degree, which will be equal to 0. And this is the equation when you resolve vertically. So it is written here. And if you need N, you can take this outside. So 580 into 9.81 sine 55 will become plus, and this will become minus. And let us keep this N and let us resolve horizontally. If you resolve horizontally, P into cos 35 degree, which is right hand side, which is plus. So plus P into cos 35 degree, and the frictional force is acting left hand side, it is mu into n. So minus mu is 0.25, n is we have written here, the same value we have written, and the other force is the self weight, that is 580 into 9.81 cos 55 degree. So which will be acting at right hand side, and this is plus. So if you resolve this, you will be having only one unknown. So you can take it the rest of things outside and divide in order to find P as 1.218 Newton. So if you apply 2181 force, it will be dragged downward. Okay. So now the third condition. So you have found out that you need 6550 kilonewton in order to move this object upward, and you need 2181 Newton to drag this downward. So in between that, so from 2181 to 6555, what will happen if you keep on applying some force? That is, you can apply 2200, 2300, 2400. If you keep on increasing the force in the upward direction, what will happen? This object will not move due to the friction. So when the load which reaches 6550, then the object starts to move. So the friction plays a major role here, and it takes nearly 4000 Newton of force due to the friction and due to the angle, and it takes that much of force in order to change its motion from static to dynamic. So this is the impact of frictional force. So after calculating, we can see that the friction plays a major role, and the amount of force which is required to make the object to move from one direction to the other, and if you want to pull the object or if you want to push the object, according to the frictional coefficient, the object carries more or less number of force. So according to the given data and the cases, you can particularly identify and in what force the object can move, in what force the object can drag downward, and in what force you can keep the object in the rest. So you can make the aeroplane to move, fly faster, or you can drag it down, and this is the same principle which we use in aerodynamics also. So there are more concepts to add that. Right now we are only discussing the friction. I hope that this concept would have given you the quantification of friction, how to quantify and what is the impact of friction. You can try it out for physical things, and you can implement, you can experiment in order to understand it physically. And I hope you enjoy this session. See you soon. Happy learning. See you again. Thank you.